All right, here we are with the last video in chapter 1. So 1.4, rewriting equations and formulas. So an equation that has two or more variables is called a literal equation, okay? To rewrite the literal equation, solve for one variable in terms of other variables. So here's an example, right? Here's not really an example, but just when we're talking about temperature conversion, and we'll do one of these problems later, but we have a formula for converting from degrees Fahrenheit to degrees Celsius. All we have to do is put our degrees Fahrenheit here, subtract 32, and then multiply by 5/9. And then later, if we want to solve for Fahrenheit, we can rearrange this equation, and that's what we're going to be learning how to do in this lesson, rearranging the equations, just using some basic inverse operations. Okay? So first, we're going to solve an equation with two variables for y. You may remember this in sort of like a slope-intercept form type of a thing. So we look at the equation, and so we see that the y term is here, so we want to get rid of or use to undo this first, so we're going to subtract 5x from both sides. These are not like terms, okay? So this is about as simple as it gets. Then we want to undo the multiplication, so we're going to divide both sides by 2, but that literally means to divide 6 by 2 and to divide this negative 5 by 2. So you end up with this 3 minus 5 over 2x. When I'm talking about slope-intercept form, if you can remember, you put the x term next to the equal sign, right? So this is a negative term, so we have negative 5 over 2x and a positive 3. But I will accept that, that's fine. But just, be aware that chapter 2 is going to start into slope. So we're kind of gearing up and trying to remember what we used to do for that. So let's do a few more examples. Again, we're going to solve these, and I'm going to go ahead and just set it up, if you can, in slope-intercept form. So there's the y. It's already highlighted in red on the video. So we're going to add x or undo whatever's being done. So in this case, we want to add it to both sides, right? So we get 5y is equal to, now I'm going to write the x first, positive x, and then a positive 10 because it is positive. Now I can divide by 5. That means everything is divided by 5, right? X divided by 5, that's like a 1. It's like 1 over 5x and then plus 2, okay? All right, here we have this y. So I'm going to first get rid of this. It's positive, so I'm going to subtract it because we want it to go to 0, right? Even though you think, oh, we're undoing subtraction, I need to add it. But if you added a 4x, you would have 8x. Remember, we want this term to be 0. So whatever we do to this side, we do to this side. Okay, 4 minus 4 is 0. I know it's gone. Bring down this negative 4y. Negative 4y is equal to. Now I'm going to slip in this negative 4x here, positive 1. Then I'm dividing by a negative 4. So that cancels that. I have y is equal to negative 4 divided by negative 4 is a positive 1. And then 1 divided by negative 4 is a negative 1/4. So we can leave it like that, if you can. All right. So we could, if you want to, go ahead and rewrite this whole thing as 6x plus 3y is equal to 12 to get, the y on the left. Then we'll subtract the 6x because that's the term we're moving over to keep the y on the left. So we'll have 3y is equal to negative 6x plus 12. Then you're dividing everything by 3. So y is equal to negative 2x plus 4, negative 2x plus 4. Okay, and if you kept it on, the y on the right-hand side, it's not that big a deal as we're just learning this. All right, for number 4, solve the formula for the red variable. So we have the area of a rectangle, which is base times height. We want to solve for base. So we look at the base, it's being multiplied by height. So to solve, we need to divide both sides by the h, or the height. So the base then becomes area divided by height. And that's how we could get the base by itself. Okay, simple interest. Interest is equal to the principal, the rate times the time. And we want to solve it for P. These are all being multiplied, so we can divide both sides by the rate time, both sides by the rate time. So we can get the principal by itself is equal to interest divided by rate and time. Okay? Getting ready to clear it if you need to pause. Okay. If we need to, we can watch this in class tomorrow. All right. But I'm going to be doing one sort of similar, and then we'll see what we need to do. So we kind of need to go back to that formula at the beginning. I think it was on so it says the degrees Celsius is equal to, and it's the key idea. So if you want to turn back, you can look 5/9, and then we had Fahrenheit minus 32. Okay. So it says room temperature is considered to be 70 degrees, right? Suppose the temperature is 23 degrees Celsius, and we don't know, is that greater than or less than the room temperature? So we need to convert this to Fahrenheit. So first we want to solve this equation for Fahrenheit. So we're just going to work this equation backwards, right? We're going to multiply by the reciprocal of 5/9. That'll be the first thing. Let me change the color so you can kind of see what the work looks like. So if I multiply by 5/9 on both sides, right? That's going to first cancel. Oh, look, but I do know where my eraser is. Oh, Miss Kleinman. Silly Miss Kleinman. Okay. Let's try the reciprocal. I think I might have said reciprocal, and then I didn't do it. Okay. 9/5. Don't know why this happens. Maybe when you're recording 5 videos in one day. I don't know. But notice when I caught my mistake is when I went to cancel my 5s, and they weren't going to cancel. All right. So always take the time. All right. So we know that the 5/9 is canceled because I multiplied by the actual reciprocal. Okay. So now I'm going to rewrite this, and I have 9/5 times Celsius is equal to, and I'm left with the Fahrenheit minus 32. So we can add 32 to both sides. And we'll get 9/5 of Celsius plus 32 is equal to Fahrenheit. Okay, this is the form I can use, okay, and use my 23. All right, so let's do that. So 9/5 times the 23 degrees Celsius plus 32 is going to equal that temperature in Fahrenheit. So to do this on your calculator, take 23 times 9, then divide by 5. I've already done that, but I didn't do it in a step, so let's do it again. 23 times 9, I hit equal, and then I'm going to hit divide by 5, so I'm going to get 41.4 plus 32. Okay, so add the 32. So I'm getting 73.4 degrees Fahrenheit is 23 degrees Celsius represented in Fahrenheit. Is that greater than or less than our room temperature? Well, it is greater than. This is greater than 70 degrees Fahrenheit. So the answer is greater than. Okay, there we go. And I'm ready to clear the work and move on. Okay, ready for your vocabulary and concept check. Please choose one and make sure that you let me know which one you're doing and type in some words with it so that you give me some context with some of those answers that you're giving me, okay? And I will see you in class tomorrow.